Okay, here we go. So, function. If you hear the word function, what do you think of? Graph, sure. What else do you think of if you hear function? Variables? Oh, good. You think about f of x equals something? Good. Anything else? Some people think of this. Vertical. Line. Test. Some people think of domain. Some people think of range. There's all sorts of things you can think of when it comes to a function. I'm going to give you the best example I could give you for a function, okay? Sydney plays soccer, right? Okay, right, Sid? All right, so is it possible, Grace plays soccer, right? Is it possible that I could look at the box score, okay, and at the end of a game, I could look and see that Sydney scored 3 goals and Grace scored 3 goals? Is it possible? Is it possible for both of them to score 3 goals in a game? Sure, it is. So you can have 2 different inputs. See, Sydney's 1 input, Grace is 1 input, and they can both score the same number of goals. Now, is this possible? Is it possible for me to look in the box score and see that Becca scored 5 goals and 2 goals? That's absurd. You would say, well, which did she score, 5 or 2? Or did she score 7? I don't get it. See, Becca has to score a certain number of goals. She cannot score 2 different types of goals during the game. It just doesn't work like that, does it? And that's what functions are. For an input, you get exactly 1 output. You get exactly 1 output. So the definition that you guys need to memorize for your test is this right here. And this is your first learning target of the day. A relation or an equation in which every element of the domain corresponds to exactly 1 element in the range. The domain is our inputs. The range is our outputs. Timberwolves. I like the Timberwolves. Kevin Love. Okay? Kevin Love gets in the game. Okay? Is it possible that he, Ricky Rubio, Derek Williams all score exactly 8 points in a game? Sure. Is it likely that they all score 8? Probably not, but it's totally possible. But is it possible to look at the box score at the end and see that Kevin Love scored both 48 and 8 points during a game? No, that's just absurd. We want to know what he scores. There's an output, okay? There's exactly 1. So that's why functions are great, because you plug something in and you can be confident that there's only 1 output. There's exactly 1 output. And so that's what we're going to do. And so our second learning target of the day is to algebraically evaluate function values. So given f of x is 3x minus 5, or f of x is equal to x squared minus 2x, we are going to evaluate f of negative 3, f of 0, f of 2, f of a, and f of a minus b. Okay? So let's start. F of negative 3. What do I do with that negative 3? I changed the x to a negative 3, so what do I do with it? Plug it in for x. I got 3 times negative 3 minus 5. What is 3 times negative 3? Negative 9 minus 5. Negative 14. Bada bing, bada bam, bada booski. No problems here, right? You guys are like, this is gravy. F of 0. Negative 5. F of 2. 1. 3 times 2 is 6. Minus 5 is 1. Carissa D, what up? You should know that function notation. I don't care if you do it on your assignment, but if I ask you to do it on a study guide or test, you should be able to do it. F of a. Well, now I got a variable. What do I do with that? 3a minus 5 I get. Can you do anything with that? Nope, you can't combine those terms, so you just leave them. Now I've got f of a minus b. What do I do with that? Plug it in. Distribute my 3. Very good. You guys are smart. Holy cow. I tell you, Miss Nelson sure didn't say very nice things about you, but I just won't believe her from now on. Just when she gets confused. I'm kidding. No, she doesn't watch videos. But I need to give her her assignment, so you reminded me to do that. How about this? You go ahead and do problem B on your own right now. See what you get, okay? See what you get. Is this what you guys have for the first four? 15, 0, 0, and a squared minus 2a? Any questions on the first four? Then we're going to go over the last one together, f of a minus b. When I plug that in, I get a minus b quantity squared minus 2 times a minus b. How do I do that? How do I simplify that? It's already factored. I'm going to FOIL it. Okay, so I'm going to multiply this out. A minus b quantity squared is... and I distribute the negative 2. I get negative 2a plus 2b. And that is my result. You've seen this before, correct? You did this back in Algebra 1, you've done it in Algebra 2. You know how to evaluate functions. Now you also know the definition. You're going to have it memorized. You're going to practice it on Monday. You're going to practice it against a partner. Whoever wins is master of the universe. Whoever loses has to buy treats for the entire class. That's what we'll do because we want to eat food. All right, so let's look at C. Any questions on the last one before we move on? Okay, then let's do C. These are different. This is new. You should not recognize this most likely. These are called piecewise functions. Anybody want to guess why they're called piecewise functions? Yeah, there's pieces for different domains. So these are the pieces right here, or the different functions that you use. And then this is their given domain restriction. So we don't evaluate 2x minus 1 for all values of x, just for x values that are less than 0. Now, I'm going to take the values from above, negative 3, 0, and 2, because we're, just from the previous problem, we're going to evaluate those. I won't do a or a minus b because that doesn't work in this scenario, okay? But what do you think? If I evaluate f of negative 3, do you think I use the first one, the second one, or both, or none? Both. I don't actually use both. It's a good guess. Anybody want to guess? I use one or the other. Is negative 3 less than 0, or is negative 3 greater than or equal to 0? It's less than 0, so therefore I use the very first one. You have to see what your domain value, domain is your inputs, your x values, what does it satisfy? It satisfies less than 0, so I use this one. 2 times negative 3 minus 1. What is 2 times negative 3 minus 1? Negative 7, okay? If you look at the next one, it's f of 0. For f of 0, do I use the first one or the second one? Why? Yep, 0 is greater than or equal to 0. So I have negative 1/2 times 0 squared minus 3/2 times 0. Looks like everything is multiplied by 0, so therefore I have 0. For 2, do I use the first one or the second one? Second one, and I plug it in, negative 1/2 times 2 squared minus 3/2 times 2. 2 squared is 4 times negative 1/2 is negative 2. What is 3/2 times 2? 3. So negative 2 minus 3 is negative 5. Those are my values. Those are my values. Any questions how I came up with those? Yes. Yes. These are my domain values right here. They are -3, 0, and 2. And if I look at the restriction on the domain, that tells me where I plug them in. So since -3 is less than 0, I use the first one. Since 0 and 2 are greater than or equal to 0, I use the bottom one. So let's do the same thing here. F of -3. Do I use the first one, the middle one, or the bottom one? The first one, because -3 is less than -1. So I have 2 times the cubed root of 5 minus -3. What is 5 minus -3? 8, cubed root of 8, times 2, 4. Good. F of 0. Do I use the first one, second one, or third one? Second one. Is there anywhere you can plug the 0 into? The function always has a value of 18. It's like a horizontal line that goes through 18. So it doesn't matter what you plug in for the domain, you always get a result of 18, it says. We have nowhere we can plug it in. So that's what it is. F of 2. You plug it in for the last one. And what do you get? 16. So just look and see where the domain value fits in these restrictions. That will tell you which of the 3 to use. Question. Excellent. Let's look at this example real quick. Okay? Okay? Let's say that this is your function, x plus 1 for x less than or equal to 1, and -3 for x greater than or equal to 1. Now, I don't have you guys doing this yet, so I don't want you to get too confused, but we're actually going to sketch these graphs. Do you remember what the graph of x plus 1 looks like? Is it a line? Is it a parabola? What is it? It's a line, and it passes through positive 1, and it has a slope of 1, and so it's going to look like this. And it only goes to a value of 1, okay? So it only goes to value 1, and I close the circle on it. So that's what the piece of that function looks like. That's what the piece of that function looks like. Then you look at -3. What kind of graph is that? That is a horizontal line that goes through -3, and it looks like it picks up for values bigger than negative or bigger than 1. And it has an equal sign, so I go like that, okay? So that's what you have. Now, let's answer Cade's question. He says, what if it fits more than 1? Watch. F of 1. Okay? Should I plug in the first one or the second one or both? Yeah, but there's a problem here, everybody. Does this pass the vertical line test? It doesn't. It fails the vertical line test right here. Right? You would have to take this off and have what we call an open circle. Then it would pass the vertical line test. Well, then where would you plug in 1? The first one. So the answer is the question never arises, because if it fits into more than one spot, it's not a function to begin with. Good question. There you go. Flip it over. All right. So I'm going to teach you how to use something today that you're going to use as you work in a calculus. We're going to continue to evaluate functions for different domain values, and we're going to use a little formula. This is confusing the first time you see it, but with all the other classes, by the time we've gotten done, they've been like, yes, that's okay, I get it, I understand. We're going to do 4 examples. Now here's what we're doing and what we're preparing you for. How many points do you need to find slope? 2 points. In calculus, we just need 1. Yeah, I know, it seems impossible, doesn't it? In calculus, you could just have 1 point, and you can find the slope. It's absolutely amazing. Your brain explodes, and then we call the paramedics. So, this is something that you use in order to find slope just using 1 point. So the idea is, if you have an equation for a line, or an equation for a graph, and you have a point on that graph, there's a line that touches tangent. It just passes through 1 point, say -1, +3, something like that, okay? And you can find the slope of that tangent line at that 1 point. It's super cool. It changed the world forever. I'm serious. You wouldn't have airplanes or cell phones or anything without it. You don't believe me? Fine. I'll prove it to you on Monday. I'll come back with a story. Come back with a good story, and you'll say, wow, I appreciate calculus more now than ever before. Yeah, no, it's really cool. It made everything work out. So this is really neat. We're going to make it work. And here's the steps, okay? I'm not going to use the whole piece yet. I'm going to just do some scratch work to help me out. F of A plus H. That's what this first part says. Everybody see that? What do I do with the A plus H? Plug it in. And I get A plus H squared. Everybody okay with that? Good. We move on. Now I'm going to do this part, the F of A. What do you get if you plug in A? Good. Everybody okay with that part? Oh, we're going to get to the minus. So now what I'm going to do is I want to evaluate this equation. This equation says take the top one minus the bottom one and divide by H. You see that? So I'm going to take the top one, A plus H, I'll square it, as it says. I'll minus the bottom one, A squared, and I divide by H. So again, the stuff in red, that's just my scratch work, okay? That's just scratch work so I can set the problem up correctly. The part below it, that's what I'm actually evaluating. So let's simplify that and see what we get. What is A plus H squared? Good. FOIL it out. A squared plus 2AH plus H squared. Minus A squared divided by H. Now here comes the fun part. And you were thinking to yourself, it's all fun. How can he categorize one as more fun? That's what we do. So what cancels? A squareds cancel. What do you notice about what's left? They both have H's in them, and there's an H on the bottom. So I can factor an H out of the top. H times 2A plus H all over H. I factored an H out of the top. Now what can I do? Cancel off my H's, and you're left with 2A plus H. And that thing that we came up with, this thing right here, eventually someday will allow you to find slope at just one spot. Which is really cool. And change the world forever. You see it? So here's the deal. As we do the next three, the H on the bottom will always go away. If it doesn't, you did something wrong. Second of all, everything that is up in the numerator that doesn't have an H is going to cancel. So let's see it play out in this next one. If you don't get it the first time, it's okay. Generally, it takes a couple times to kind of chew on it. It's kind of like steak. You gotta chew on it for a while, right? Who really likes steak here? I'm a big steak fan. Good stuff. G of A plus H. Again, we want to evaluate G of A plus H minus G of A. Hey, don't do that. All over H. That's what we want to evaluate. We want to do that big piece. So I'm going to set up the two parts that I need to evaluate in order to carry out the whole operation. What do I do with my G of A plus H? What do I do? 2 times A plus H minus 3. What about the G of A? Plug it in, and you get 2 times a minus 3. Any confusion from anybody where I got those? Okay, so let's go to work. I've got 2 times a plus h minus 3, so I need to take the top one minus the bottom one divided by h. The top one is 2a plus h minus 3 minus... Uh-oh, I got to subtract the whole thing, so I better put that in parentheses. That way I'll remember to distribute my negative. Divided by h. Cool. Simplify. 2a plus 2h minus 3. Now what? Minus 2a. No, just plus 3 divided by h. What cancels? The 2a's, the 3's, everything that doesn't have an h. You're left with 2h over h, which is dos. Spanish for 2. I'm bilingual. I can say a lot of numbers in Spanish. At least like the first 5 or 6. 100? I have no idea. 1,000? Diaz. What? Nil? Nil is like none. Mil. Like millimeter. Not like meal like I'm going to eat. Like millimeter. Right? See? 1,000 meters. Well, 1,000. 100. Duh. Oh, okay. I only took 1 semester of Spanish in my life, so. Okay. When she found out she wanted to back. All right, okay. So, and I said, no, I'm too good for you. Okay. Here we go. We got to do h of a plus h. So 5 times a plus h minus a plus h 20 squared. It's my only memory of Spanish. So other than dos, I know dos is no. Muy. All right. H of a is what? 5a. Very good. 5a minus a squared. So now what operation do I need to do? I need to take the divided by, very good, top. 5 times a plus h minus a plus h, quantity, squared. Minus parentheses, 5a minus a squared, all over h. What's up? Sure, you go ahead. Yep, if you want to distribute right away, go ahead. I just want to make sure I write it out so you see where everything comes from. Okay? So now we're going to do what Sydney said, which is distribute 5a plus 5h. Oh, now I got to distribute the negative, don't I? So let's square it first, and then we'll distribute. So if you square it, you get, so negative a squared. In the middle, you get 2ah, so we'll minus 2ah. And at the end, you get h squared, so we'll minus h squared. Now I have to distribute my negative, minus 5a plus a squared all over h. Oh boy. Okay. Well, if we did that right, what should happen? Everything without an h should cancel. Does 5a cancel? Yes. Does a squared cancel? Yes. And that's everything that doesn't have an h. So everything that's left does have an h, so I can factor it out. Spread it over h. and the h on the bottom divides out. Yes, Alexa would. Nope, because I have a negative in front, so I'm going to subtract it, so I have to distribute it even from the beginning. How would you like to write it? Negative h plus 5 minus 2a. Awesome. You're A plus, Carissa D. No matter what Cini says, I think you're cool. All right, last one. Ramp up. Get ready for the big stuff. Here we go. What is k of a plus h? Wow. What's k of a? So I take the top minus the bottom, divide by, let's do it. Top 3a plus h quantity squared minus a plus h plus 2 minus parentheses 3a squared minus a plus 2 all over h. Oh boy. I square out the a plus h, I get a squared times 3. 3a squared. What do you get in the middle? 6ah. Very good. What do you get at the end? 3h squared. Minus a. Minus h. Plus 2. Minus 3a squared. Plus a. Minus 2. All over. What cancels? Everything that doesn't have an h, if you just go through and find it, it should all cancel. And when you divide out the h, you get 6a plus 3h minus 1. Isn't it beautiful? Question. Not for polynomials. If we got to radical situations, others, we would find some situations that we would not know how to deal with. Oh, yeah, sorry. Nope, only where it says f of a plus h minus f of a over h. That's so in your assignment you'll see some of that. Got it? Here's your assignment. A lot of these are plugging in function values, like plug in 2, see what you get. Plug in 5, see what you get, so on and so forth. Please do not let this sit till Monday, especially the new stuff that you learned. Piecewise functions and the f of a plus h stuff. That stuff you need to practice right now, you know, like the next couple days. Then you need to sleep, because that's how it stores to your long-term memory. And if the only thing that you remember from this class is my story about Spanish class, then at least you got a good laugh. You never thought I was such a deviant, did you? I was a naughty kid. Then I found math. Math found me, more like it, I guess. So, all right, way to go.